please remind me as well. Okay, so we're gonna start where we left off last week. I hope that we can finish this lesson list today. Okay, so if we have the program written like this, okay, I can just run it first. This is the data diagram to show how the data are stored in the list and in variable logically. Okay, so for example, for the first line, right? Whenever you have seen the assignment, it means that in the Python program, they create a storage to store the variable names and then creating the pointer to point a value, okay? And a list is a collection of storages, a collection of containers where each position points to a value that is assigned, okay? Understanding this is beneficial in this class to understand what's gonna happen when a variable or any variable is changed. For example, if I change one variable, like I reassign drink to Long Island instead of pimps. So, and then I ask, maybe in the exam questions, I ask, what is the value that drink is storing and what is the value of this list at the position 1. Oh, actually, I haven't taught you yet. Yeah. Okay, so maybe this one we haven't seen before. So what I ask is what is the value of the order, okay? So what happened is that we reassign the drink variable to Long Island. What happened is that the program will delete the pointer of drink variable and then create another pointer to the correct value like this. So you can see that the order containers here, the pointers are the same, right? So at the second position here, the pointer still exists and points to the same value pimps. So what happened in this program is that drink has changed the value from pimps to Long Island, but the list name order it still has the same value in the second position. Okay, maybe have another example. If I change the search here to I reassign the search to a new list, so it means that this pointer that the search has from the original is deleted, right? And then this container has another pointer, create another pointer to a new list that contains pancake and 3. Okay, so when I run this, the search has changed the value to a new list because this is reassigned to the entire list. Okay, but for the order, yeah, we can see from this, right? The search is used in this position before, right? But what it is just the same list as before because this pointer is not affected by reassigning the desert to any value. Okay. And I mean, this is an extra information that you can have a look, but this is out of scope of this class anyway. That you can check the ID, which is the ID of the container, by using the function name ID, and then you put the name of the variable inside. We can see that drink has another, drink and dessert and order have different IDs, meaning that they have different, they are different containers. Okay, and this is I spoiled you before we going to study what it is. This is This refer to the first position in the list. This refer to the second position. We can see that each position in the list has different IDs, which means that they are different containers. Okay, and the next topic is about indexing, which is important in this lesson. Okay, from now on, it's very important in this lesson. Before it's just the introduction. Okay, indexing, why we need to learn this? Because we want to access each element in the list individually. Okay, we can access each element by specifying an index inside the bracket, like square bracket like this. Okay, if I have the data as the list, right, like this, and then, to run data first. Where is the data? Okay, I created data here. Data is a list of 1, 2, 3, 5 elements already. And now I want to access each element individually. Okay, what I can do is I use a positive index. So for the first index, I need to specify 0. So when I maybe if I can print this, because this is not print, I need to use the print function to print the first value that is kept in the first position in the data. So I can get the first one by specifying 0. Okay, so just remember that the first position starts at 0. We use 0 index system. So you can guess that for the next position, the index is 1, 2, 3, 4, and so on. But we have just only 5 elements or 5 items. The last item has the index of the number of items minus 1, which is 4. Okay, and this is just a demonstration that I can access each item individually. Maybe have a look in this one. So this one, because the last item is a list. So what we are seeing here is just a list, okay? Because list can hold any data types, okay? And what happens if I specify the index that more than the size of the list? Here, the error will occur, like index error. And it says that list index out of range, which means because the last index of the positive index, we call this positive index. You can guess that we're gonna have negative index later on. Okay, so for the positive index, it starts with 0 to n minus 1, where n is the number of, where n is the list size. Okay, so this is the last index, right? That's why 5, 6, 7, and so on are index out of range. You're gonna get this kind of error. Okay. Okay, and we have the negative index system as well. Okay, how it works is that if I copy data here, Okay, there are 4 elements here, right? So before that, the index is 0, 1, 2, 3, 4. When we use the negative index, it is counted from the right modes, starting with -1. So you can guess that this is -2, -3, -4, and -5. Okay, So you can notice that this, like for the first position, it is minus n, where n is the list size. Okay. And then I will show you that we can access or we can get each value individually here. Okay. At -5, we're gonna get chicken with rice, with basils. Okay. And the same as before, that if we use the index that is not like, that is out of range, right? The error will occur, like index error, less index out of range. So whenever you see this error, you need to check if you find the index correctly. Okay, easy, right? So for the next topic is about this one, we can access each element individually, like one by one, but actually we can access multiple elements in the list by using what we call index slicing. Okay, so this is the kind of the pattern that we use. Anything that is inside this kind of bracket here, like I don't know how to call it. Okay, you can use your own like variable. You can put anything inside, but this is fixed, which means you need to use bracket to access, like to access the values inside. And when you want to do slicing, you need to use colon to separate between the start position, the end index, actually the starting index, the end index, and step that you use to slice. Well, we're gonna see an example here. We use the same example, data. Okay, you remember all of these elements already. So if we write like this, data bracket, and the first position in the bracket is 1 and colon 3 here. What it means by this? It means that it uses, we can see that it uses the positive index, right? And if I can write down here, so we can use 0, 1, 2, 3, 4 in this example as the index. And 1 is like this. This columns means like until. So from the first index until the third, but the third position, we don't want it. So it's gonna print out 1, yes. The position, like the third position in the list, but it is the position when the index is 2, yes. But this one for 3 is like, it's kind of a convention in Python that for the last one, if it is the n index or the n in range, the n parameter in the range function, we're not going to use that position or that number, right? So for this position, we don't want it. So this gonna extract 2 elements of the first index and the second index. Okay. Okay, and that is the default value for the starting index and the end index. If we, this is okay, so I want this actually. Okay, if we don't specify any value for the starting index, it implies that it's gonna extract from 0. So this is gonna extract from 0 here. So we're gonna get chicken with basils until this position, right? Until this, because this one we don't want it. We specify that the last one should be 2 minus 1, which is here. Okay, so for this one, it's gonna extract the first 2 elements here before the second index. Okay. Similarly, if we don't specify the n index, okay, if we don't specify the n index, it means that we're gonna extract the elements until the end, until the last elements, which is like from the second index. So from here to here. So this gonna extract 3 elements, right? Here, false, and the list here. Okay, and we can see that for these 3 examples, we didn't specify the step size, which means that the step size is 1 as the default value. Okay, and we can use the positive index system with the negative index system as well. Like here, maybe I can start from here. Maybe here. Okay, so what it means by this. So if I write the positive index system at the top, and then I also write down the negative index system below here. Okay, so 2 mean this position, right? And -1 meaning this position, right? And if I don't say the step size, it means that the step size is +1, meaning that it's gonna go this way, right? Okay, so this code gonna extract this element, but not this element, because this element is specified at the index as the end index here. Okay, so this one gonna extract 2 elements. See here, get it? Okay. Okay, if you have any questions, you just send me via the chat, Zoom chat, and then I will answer it later on. Okay, so for the next example here, what's gonna happen if we know that the index of 3, like 0, 1, 2, 3, 4, right? 3 is here, so start from here, and then the start position, the end index is here. But because we don't specify the step size is +1. So like the direction to extract the data is like to the right, right? Okay, but the end position is on the left. What's gonna happen in this case? There is no error happen, okay? But it returns, when I say it returns, actually it's not returning function, because this is the function, okay? Okay, it gives us an empty list, because we want this position, but we cannot go to the right because the end position is on the left. So what it gives is an empty list. Can start this. Okay. Okay. And one of your friends asking if I write to, like, if I want to extract the position 2 to 5, what's gonna happen? We know that this is like the data has the last index of the data is that we can access is 4, right? 5 is here, this is out of range. So, but when we use the index slicing, it means that, okay, we start from the second index here, we're gonna get this, we're gonna get this, and we're gonna get this as well, right? Because this is the end index, we're not gonna get this, right? Okay, so I guess the result's gonna be there are 3 elements until the end, until the last elements here. Okay, so that I have another question. So if you are confused with this slicing, you can try on yourself as well. Okay, if you use 6, which is like out of range because we don't have the index of 5, in the data, what happened here. You can see that there is no error actually, but it extracts until just the last element. So this can be out of range. Yeah, so Nita asking for this example, it doesn't give even the third like the value in the third index. No, because it is wrong at the beginning. Yes, it is somehow like how range function works, but it is not a function. The convention is quite the same. Okay, so this is an example when we specify the step size. Okay, so this means that we have this index, right? And this will start from 3 here, start, and end here, right? And normally we're gonna go right, but for the step size here, we specify to go on the left. So it is correct direction. So we're gonna get 3, 2, but not value of the index 1, right? We're not gonna get like we get this number and false. You can see up here 0, 1, 2, 3, 4, right? So 3 first, because 3 is the starting index. 3 first, and then 1 is the end. We're not gonna get this. We get just 2 elements, and in the reverse order. Okay, because the step size is negative. Okay, and I have seen that many of you use this kind of convention to answer the lab exam. What is this? This is the reverse, reverse all positions in the list, because we don't specify the starting index, we don't specify the end index, which means that we're gonna extract the first position until the last position with the what? With step size -1. Okay, so this gonna reverse all positions in the list. Okay, I have a quiz here. Before you run it, can you do by hand to say what is the data, what are the elements in the numbers? If numbers is a list of 2, 4, 6, 8. Can you do it now and then answer me on the chat? Anyone? But 6? What is 6 equal 4? What do you mean? 6 and 4? So I guess, 6 become 4. Okay, so when I print number, it's gonna give like 2, 4, 4, 8, right? Okay, we'll see. It 4, so it changes, the last 2 elements are changed to 4 and 4.0. We will see how this happened. Okay, first number is this, right? Okay, and then so for the second line, we extract this index. 0 index, which is 2. So this will give us the value of 2. So 2 times 2 is 4. And then 4, because this is what index? The index is like at the 6 here, right? At this position, right? Okay, so if I write down here. And I write also the index above. Okay, the index of 2 is here. And then we assign 4 to this position. We assign 4 to this position. This gonna change to 4. This gonna change to 4. Okay. And for the third line, we access the last element, which is 8 here, which is 8, right? And we divide it by 2. It gives 4.0 because it gives us a floating point. And then we assign to the what? To the last position. So the last position is here. And then 4. This is gonna change to 4.0. Okay. And then it will give us here. Got it? What I haven't said that is that when we access each individual element in the list, we can reassign or we can modify it as well. Like we can reassign a new value in each position as well. Any questions? Okay. So the next topic is about iterating over a list using for. We know that for is used to iterating on something, on a like range, which gives you a kind of a collection of numbers, right? But because a list is a collection itself, so we can iterate over each element in the list. And this is kind of the pattern that we use. We use for and then followed by a variable name. You can name anything, okay? And then you use in, and then this is the list that you want to iterate. And then followed by this, before that we need to follow by a colon to create a for block here. Okay, this is an example. If I print out first what is inside order. Okay, here. And we want to iterate, or we want to access each element individually, like every element in the list, instead of using like the index system like this, right? If I want to print it out, what I have to do is I need to print, and then I need to write the kind of indexing, right? And then I need to repeat it over time, like for 4 times, because order has 4 elements like this to print everything out. Instead of this, I can use a for loop to iterate each element in the order using just like 2 lines of this. Okay, so it means like the meaning is quite straightforward, that for item in this list, print it out. That's it. Okay, you can change item here to any variable name, like maybe I. Okay, I usually use item so that I understand, I myself understand that items refer to each item in order, in the list name order. And you can see that the order is still the same, right? It accesses the first position, the value of the first position, the second position, the third position, and the last position. Okay, so this is the first method to use for to iterate each item in the list. But there is another method we're going to talk about that later on. Okay, so I have a question for you before we go to method 2. I have 2 questions actually. The first question is, with this program, for item in order, and then in the block of for, I change the value of item here to something else, to this string. I reassign item to this string. Then I print item, and then when I finish iterating all like each item in the order already, I print again order, the list of order. What is the result of this? Print 4 times and then print the elements in the list order. Yeah, correct. But what is the elements in the order? Do you think that it is gonna be like this, like 4 sets of this question mark string here, like this, because it changed the item here already? Okay, anyone think that this is the result of the last line of this program? Type Y, and then if anyone doesn't agree with me, so type N. N or Y? In this case, N or Y? Oh, so some of you answers N. No Y at all? Okay. Oh, there is one Y here. It means that I can use this maybe in the exam then. Okay, we'll see. I just run this and then see the result. See? Okay. For this one, right, it iterates 4 times because the size of this list is 4. Remember that, right? And then when it iterates at the beginning, item will like have the value of salad for the first iteration, but for the second line, we change the value of item to this string. So each time the value of item will change to this string before it is printed out. So we're gonna have these 4 lines of the output. But when this item is changed, remember that if you still remember the diagram, order is here, right? It is a container that points to another container where it contains multiple small containers here, and each one point to the value, like salad, Pim's 40, and this is another list that point to panna cotta and 2, right? And item is like for each iteration, the program create a variable named item and then point to salad for the first iteration, and then it changed to string here, right? Okay, when it changed to string, what happened is the pointer of item changed the place to the pointer of item has changed the destination, but the first position of the order still has the same pointer, so it points to the same value, which is salad here. So when I change when I reassign the item variable here, it doesn't affect the elements in the order. Okay, got it? Okay, so next question is that write a program that receives a list of number from the user and print out the average. Okay, we can do together. Okay, so thank you, Natakiet. We have a code from not yet. Okay, if you have any other solutions, you can just send me via the chat. Later on is fine as well. Okay, this one, not yet, gives the num list already. Let me change here. Yeah, I know that we can get it there. Okay. Instead of using this, actually we need to like is the input, right? Input maybe a list of number. So enter a list of numbers here. We change it back first. Okay. And remember that if you split, so assuming that the users will give us one line of the list of number using space in between. Okay. When we use split, remember that the split function will return a list already. So we can just name it just one variable instead of before we have to create the variables, the number of variables equal to the number of the split function return, right? But this time, because a list is a collection already, so we can have just one name. And okay, imagine that we have, for example, a list of 1, 2, 3, 4, as Natalia gave us an example before. When we want to calculate the average, oops. Oh yeah, we need to, yeah, I will convert it later on to float. Okay, so when we want to calculate the average, we need to calculate the total first, right? The accumulative summation first. So we set up, like we initialize a total as 0 before at the beginning, and then for, so when we read this, for each num, say num, right? In num list, this is straightforward as an English say. Okay, total is equal to total plus num. So for the first position, num gonna be like 1. And then we sum it up to the total. And then for the second iteration, num gonna point at the second position, which is 2. And then you sum it up with the total variable. Once you finish it, this one is actually the summation of 1 plus 2 plus 3 plus 4 already, right? And so on if you have more in the list. And then you get total, and then you want to, you want to average it. And we know that when we want to average, we need to divide total by the size or the number, the size of the list, which is the number of the elements that we use to sum it up. Okay. Do you still remember that we use length, which stands for length of num list? We're gonna get the size of that list, right? And then print it out. 1, 2, 3, 4. Oops. Yeah, I forgot. I told at the beginning that I wanted to convert num from string here to float, but I still forgot. Okay, we need to convert num here to float because actually after the splitting here, we're gonna get a list of string because everything gonna be string in the input, right here. So before we sum it up, we need to convert to float first. Thank you, Nida. Yes, that is correct. Yay. Is that the average? Yeah. Okay. You can try other examples, but I think this one is correct. Okay, got it? So for this one, we know how to iterate each element in the list already. Okay. But what if I want to modify some positions in the list? We know that if we want to modify like if num list at the beginning is a list of 1, 2, 3, 4, like this. Maybe it's the string, right? Okay. If I want to modify each element to float, how can I do that? I cannot, like, whoops. Remember that many of you have tried this before, num list. This gonna give you error, right? Because float requires just only one element. Not one parameter, but this is like one basic data type, like string or integer or float, right? But this is a list. It doesn't meet the requirement of the float function. We cannot do that. So if I want that, right? So maybe I create another example. Like here. Maybe what I want is convert each element in the list to float. Okay, what I have to do is I have to do like list at the 0 position, the index of 0. I need to change each element individually, and then I need to reassign to the first position, like reassign back to the first position like this, right? Okay, and I have to do this for every position. So do this, but this is not a perfect code because actually we don't know, like we don't know the size of the num list. So we don't know how far we're gonna do this, right? Okay, this is not a perfect. This is not a perfect program. Okay. Yeah, thank you, Nida. So we're gonna use method 2. Because we have a convention to iterate the index in, we can use the index in the, actually this one, we need to, before we learn this, like before we can see this pattern, actually we should know, right? If we think further, we can see that the index has changed, right? And then we don't know, we kind of guess we're gonna go how far we can go. We can go to the to this one, right? So we can go to n minus 1, because where n is the number of elements in the list, right? Okay, so what is changed is that we can see the repetition here, and we can see just what is changed is just the index, which is just in number and integer. So we need to use for loop, right? For, and then I in range of what? From 0 to n minus 1. So 0 actually is not necessarily written down here. So like until n is the number of element, which is the list size. So we can just say this, right? And do we need minus 1 here? Yes, thank you. We don't need minus 1 here because range gonna generate the number from like 0, 1, 2 until dot 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 until n minus 1 already, right? Okay, we don't need to use it. And then we can use this line just one time because it is repeated automatically under the for block. Then we need to change this as well to I. Okay. Yeah. Nida understands it correctly. Okay, so for this one, and then I'll print it out first. Num list. We will see if it works. I print it here as well to see if the value of num list here are the strings. Okay. 1, 2, 3, 4, 5, 6. Okay, that's enough. Here, see. You can see that it changed each variable correctly. Okay, so the method to iterate each index in the item, the advantage of this method over the first method is that we can modify the list. It is not necessary though. I mean, we can print something out as well, like this is the same output as before, right? But we can just, this allows us to use the index to access each element. Okay. But if we have the question like this, like we need to reassign or modify the list, right? We need to use this method only. We cannot use the first method because the first method we cannot use the index system. And once we cannot use the index system, we cannot modify the list. Okay. Okay, so here. Write a program that receives a list of numbers and print out the average using method 2. Actually, this is the same question as before, but I just changed the method to iterate over the element. Okay, if I copy it here, what I change is that I will change num here to maybe I to stands for index or IDX maybe. We can use whatever name here. And we need to change here because we need to iterate or enumerate the integers, right? Because we need to use the index. So it's here as before, right? And when we want to sum, we need to access each element by using the list name, and then index inside here. The result will be the same. It gives us 2.5. Okay, cool. So for the next question. Okay. Actually, this is the exercise of list slicing. I will move up. Okay, let me move up to the slicing section. Sorry for this. But you can do this and then send me the answers. Here. Okay. After this. Okay. Let's do this by hand, maybe. Okay, to extract the value, this is the value, okay? 2, 3, 4 here. So we need to know what? We need to know the index. So 0, 1, 2, 3, 4, 5. This is the positive index. And this is the negative index system. Okay, to answer this one, I can copy Nida code here. Okay, so we want to extract 2, 3, 4 here, which starting from what? Index of 1 to 3, but we need to write 4 down here because it needs to extract the element before 4. Name error because I haven't run this. Or numbers, actually numbers. Wait, numbers. Oh, not numbers here. Sorry. Numbers. There are, I think, more than one way to write down, okay? To write the code because at least we have 2 indexing system. First one is this. Need to say print it down. And also we can use the negative index as well, like -2. Actually, I need to say -4 here first, right? -4, 2, -2. Oh no, -1. Wait, -2 here. Because the first element that it's gonna extract is this one, and then I need to go on the right. So the step size is +1 until, oh, actually, I am wrong. Need to be -5 because the first is here, right? And go there, +1 and 2, 3, 4 here. So we need to write at the write down the n index is -2. We see if I am correct. Yay. Okay. So okay. Then okay, this is for the first question, right? Okay. For the second one, we need to extract 1, 3, 5. 1 is here, 3 is here, 5 is here. We can see that the step size is 2. So the step size is 2. What is the first position? The first position that we need to extract is 0. If it is 0, we don't need to write it down, but I write it down here maybe. And 1, 3, 5, and we want the last element here to be extracted, so we need to use the index of 5 here. Okay, to see if it is correct. Yeah, 1, 3, 5 here, it is correct, but this is not the only way to extract. We can use this as well, and also we can use the negative index system. Okay, 1 is -6, and until, oh yeah, I am wondering if I can use the mixed index of negative and positive here. Yes, we can use this. Okay, we can use the negative index system and the positive index system as well. Like we can use it the mixture of them. Also, another way to write it down is because it is 6. You can see that the number of element is 6. So the first position in the index system is minus length of numbers. Okay. Yeah, there are so many ways to write it down. So I leave it as your homework then, blah, blah, blah. Because you can just write down your code and then check if it is correct by yourself. Okay. Okay, let's go back to the iteration. We know 2 methods to iterate each item in the list already. Okay, so the next topic is about list modification. Actually, this one we have used it before. Sorry for the unordered content here. I will move up later on, maybe next year. Okay. Okay. This is as with. Okay, this is the same example. You remember the diagram, right? Okay, and then I will replace the second item in the list. The second item, I means the index is going to be 1, right? Because the index is started from 0. And then I reassign the second element, the second position, like from drink, which points to Pimps. So Pimps is here actually. I change it to Long Island, okay? And then I change as well the first position here, salad, to mango sticky rice. So order now has changed value to, wait, this is dessert again, okay. I was wrong before, okay. So order now is like salad is the same because I haven't changed it, okay. This one, mango sticky rice, I changed it in the list of desserts, okay. I can write it down quick here. That's okay. I think we can understand it without the data diagram as well. If you are not sure, you can just write down your own, like your data diagram yourself, and then see if you understand it correctly. Okay, again, and Pim's here. Because I haven't run this, sorry. Run this and run this and run this. Okay, so now we can see that the first position here, right? The first index position is changed to Long Island already because I modified the list directly. Okay, so for this one, I changed the first position of like the 0 index position of desserts. Desserts here is here, right? The 0 index is panna cotta. I changed to mango sticky rice. So for this position, imagine that it is a storage or a small container that points to panna cotta. When I change it, it means that that pointer is deleted, and then it creates another pointer to point mango sticky rice. And then it affects the value of the desserts, right? But the desserts is used in the last item of order. So the last item of order for the 0 index of that list is changed too. Okay, you got it? If anyone has the question or still confused in this point, just type X here, please, so that I know if anyone is still confused. No, right? Okay, so it means that everyone understands. So because this point is important, I mean, this is still in the scope of this class, so it can be an exam question, okay? So here, when I change the data, when I change the first position, not to points to panna cotta, but to mango sticky rice, what happened is it creates another pointer here. But because the last position of order points to a collection of containers, not the value itself, because it is a list. So this is the value that the container points. So this is gonna change to mango sticky rice as well. Okay. I hope that everyone understands it. Any questions so far? Okay, so next is kind of basics operations for list. So it requires some memorization because the exam gonna be like closed book exam, right? So what happened here is that we cannot use Google to search what happen function works or how to use it. We cannot open the book when we like do the exam. But actually in real life, when we code, always, all the time, I use Google all the time because I cannot remember at all. Okay, so the basic operation. This is the list of the functions that are covered in this class. It's here, like append, insert, index, del stands for delete, remove, min, max, sum, sort, and concatenation using plus stars, like repetition. This is the same as we have known before. This is like the string operations, right? I will talk about it later on. Okay, and in, the keyword in. Okay, let's start here. We're gonna go very fast. Okay, because it is a function, a list function, so the functions belong to the list. When we use, we need to specify what list that we're gonna do this operation. Okay, so we use the list name followed by dot, and then the function name, and then the parenthesis, a pair of parentheses, and inside we gives the parameters that are required in that function to be to process. Okay, for example, if the data is this list and we want to append Americano, we can use data dot append Americano. And what's happened is that Americano is appended in the last, at the end of the list, so in the last position of the list. Okay, append always adds an item in the end of the list. So we can see that here, this is list can be modified, right? They can be expand, the size of the list can be increased, also the size of the list can be reduced as well. That's why we call that a list is mutable. Okay, they can be modified. Okay, but if you want to add an item in a specific position, we need to use insert function. You see example here. Insert requires two parameters. For the first parameters, it needs the position, the index position, and this is the value that we need to insert. Okay, if the data is originally like this, and we want to insert Americano at the index position 2, this is 1, I can say this is 0, 1, 2, right? So it means that the position 2 originally is like 400 something. We want to insert Americano here. So now later we use the insert function. Now data at the index of 2, it is Americano. And 450.5 is shifted to the right. Okay, this is what happened when we use the insert function. Next is the index function. Index function is just a kind of search function. Where is the value? What is the index? So for example, if we know that if the list is quite long and then we don't want to count it, but we want to find false, where false is, what is the index of false? We can write data dot index, and then this is the value. Then it will give us 3. Okay, which means false is in the index of 3, 0, 1, 2, 3. What is true? Here, the value will, like, there is an error because true is not in the list. That's why they cannot find it, and the error happened. Okay, so I give you one more here. If I want to insert like 100 at the index of 100, what's gonna happen? Here, oh wait, I run this again. Okay, I run this. There's no error, but instead Americano will be added in the end of the list because this is too much. And then because the people who wrote this function say that if it is too much, we're gonna add at the end of the list instead of raising an error. This kind of we need to memorize because you know that a function is a people written function, right? So they can do anything in the function. This is what they defined. Okay. Okay, and this is what they define as well. Instead of returning none or returning, we cannot find a value. They raise an error instead if we cannot find that value. Okay, so next function is del, stands for delete. When we want to use this is kind of a command. You can see here, it is not a function. Okay, it is not a function. If we have data like this, and then if we want to remove the index, the fourth index position, which is 0, 1, 2, 3, 4. So we want to delete this item. So we use del space data up, and then we specify the index here. You can see that. See, the last value, the last position value is gone. We can delete multiple elements as well. 0 to 2, 0, 1, 2. So these will be gone, right? Wait, yeah, just two of them because the second index position here is not included. Okay, so we have this left. And okay, we can actually, so for this one, we can actually use del data. So what's gonna happen is that when we delete that variable and then we print it, we use it later on in the code, we're gonna have an error called name error. It says that data is not defined because we deleted it previously. So the program doesn't know data anymore. Okay. This is another example that we delete the variable drink already. Yeah, but there's no error. Why? Remember that? Actually, this gonna have the error because we run this before. I restart runtime here. So I restart a computer here. So wait. Oh, yeah, this not gonna have error because we use drink here. Okay, drink still exists here, but we delete it later on, right? Later in like line number 5, but order still have the same values because at the first index position here, actually it is a pointer to pimps, right? There's nothing to do with the drink variable anymore once it is created. You got it? I think you can imagine to the data diagram happened before. Okay, and yeah, what happened with this? This one create order, right? Imagine the same data diagram. And then when we say del delete the search 1, which means this position, right? This position will delete it. What is the order? Do you think order contains, for the last item, it contains 2 or not? Yeah, Nida say that. Okay, for this one, right? Can you remember this code? Okay, like these 2 lines. Okay, delete drink, right? I will go back to the data diagram and we'll draw down what's happened. It's quite a long way to go. Today we have learned a lot. Okay, this one, right? And then when we the drink, it means that this actually like it delete drink here as well. So and including the pointers as well. So we can see that this pointer is not affected. So it still exists. So when we print order, the program will see what is the destination of the pointer of order is here, and then what is the destination of each container, and then there are values here. Okay, but when we delete, so for the second examples, right, we delete the search at the first position, which is here, right? The search at the first position here. So this list gonna shrink to just size of one, right? Because when we delete it, remember that the elements are gone, right? So this element is gone. So the size of the list is shrinked. And because this pointer, even though it is not affected, this pointer is not affected, it still points to the same containers, that green box. So when we print it out, these positions have like, we can say, if we can see that this pointer, okay, points this one and this point this one, so there is just only one element. So if when we print pointer, print order here, so it's just this, right? So it's gonna print out for the last position, the last item, instead of a list of 2 elements. It has only a list of 1 instead. And again, and similarly, because desserts points to the same list here, when we print desserts, it contains only panna cotta because the first index position is deleted. That is why I kind of focus on the data diagram at first. I mean, in the exam, I won't ask you to draw this, but understanding this, if you can draw this when I ask you about what is the result of the program after I remove something, reassign something, what is left, or what is the output of the program, you can like answer it correctly easily. Okay, we're gonna check if what we understood is correct. Okay, this one, I run this again. The last item, we have only panna cotta left in the last in the list. I mean, the last item. Okay, instead of delete here, we can delete each element, like one element or multiple elements individually, or we can delete the variable, the whole variable, right? We can see that we can delete like the variable, no matter if it is a string or a float, an integer, or even a list. Okay, we can delete, like this is a like force delete a variable, no matter what it is. But a list has a remove function as well. They can remove a value in the list. I recommend to use this when you like, this is kind of better practice when you want to remove an element in the list. Okay, so this one, false, was in the list of the data before, but it was removed here. So finally, the data doesn't contain false anymore. Okay, so if we say remove true, which is not in the data, what's happened? Oh, what happened is like, again, this is like it raised an error, value error here, X not in list, which means like true is not in the list. Okay. Okay. One more thing that the delete here and the remove function is different is that remove requires a value, right? We need to know the value to remove. But for delete, we use the index, right? Okay. Okay. What if we know just the value that we want to delete, like for example, like this one, right? And if we want to remove, no, maybe this one. Okay, if you want to remove false, but if I like force you to use just only this command, so what I need to do, like I want to delete false without using remove, but I want to use del command. What do you think you can write now to do that? Can you give me? Yeah, find the index of false using index, right? Index of false. And then this will return an index, just only the index, okay? So we need to say that. We need to delete this. Is that correct? Haven't printed out. Print data. Okay, you can see that false is gone here. I just moved to the same block to be easily seen, okay? Okay, cool. Okay, next two functions is about min and max, to find the minimum or the maximum in the list. Okay, and for example, if we have the list of numbers and the list of string, we can find a minimum of both. Okay, but we cannot do this. If it is a mixture, the list, because a list can hold different data types. Maybe just two and split. Yeah, here. Can I find a minimum of nums and words? No, right? It's a type error because to find a minimum, we write a function of to find a minimum before that we use a less than sign, right? And this one cannot compare between string and integer, okay? And the error will be the same if we use max. Okay, so I'm gonna skip max here. Summation, okay. We can do, sum. Wait, sum is not a list function. It is a built-in function. I can have a note here. That requires that okay, sum is a built-in function that we can put a list as a parameter. Okay, use words. This one cannot be sum because plus cannot assign weights. Even though words are string, right? Okay. Yeah. You can see that we cannot use plus with the string, okay? Because why they say that unsupported operand for plus between integer and string. This one is because we want to use, remember that when you write a summation function, you need to create a variable and then initialize it to 0 at the beginning, right? And 0 is an integer. That is why we cannot sum with the string. Okay, so this error happens. Okay, another function is sort again. When we see this, sort is not a list function. It is an built-in function that requires a list. Oh, wait. I am wrong. Actually, sort is a list function. See, I cannot remember all of them. But before the final exam, I ask you to remember that. Sorry. A list. Okay, so pattern would be here. Okay, so because sort is a list function, we need to use the list first, like the list name first, like x. For example, x is this list, right? We need to say x dot sort, and sort doesn't require any parameter. Okay, so they can sort in in an ascending order, like from the lower to higher, lowest to highest. But if we print out x dot sort, we can see that what happened, it returns none. What does it mean? It means that the sort function is a void function, right? It sort and replace the same variable, the same link, like and reassign to the same list. Okay, it sort itself, but it doesn't return anything. You need to remember this. And if you want the reverse, you can just put the parameter. That there is a parameter actually reverse, but the default value is false. And then if we want to force this parameter to be true, you can write down here. Okay, this maybe we haven't seen this before as the parameter that we like assign this inside a parenthesis, but this convention we can do it. Okay, this is called positional argument. Whatever it is just to say that sort requires a reverse parameter and we want the reverse parameter to be true. That's it. Okay, we can use a plus sign with the list, between two lists as well, just to concatenate two lists. Or we can do more, actually. We can do like here. It's gonna be 1, 2, 2, 3, and 1, 2 again, right? It is concatenation. Okay, and for the star, it is repetition. It will repeat whatever in the list A. So what it uses is like we need to like, this is a list but starts with an integer. Okay, this needs to be an integer. Many of you might be familiar with this thing before, because we did this with the string variable, right? So 2.5, we cannot do that because it is a float. Okay, the last one, the keyword in. We can check if an element is in the list or not using in. So this is quite straightforward, right? It's like an English language that I said at the beginning. That okay, so print chicken with bezels in data, it will gives you true or false, just to one of these two values. Okay, so true, sweet potato is in data, false. Sweet potato, and then we can use not as well. Like sweet potato not in data, is it true? True. And we can see that these are keywords in the Python because in Colab the color of this is like blue, right? So it is keyword. And because data, I can copy it here. If you remember, data is the list where the last element is a list here. Let me copy it first. Okay, I copy it here. See, the last element is the list. So this is, oops. So this is just a list. So we can use in as well, right? We cannot use in with like one. What's gonna happen? It raises an error because this is not a list. So we can see that type error, argument type like int is not iterable, so they cannot use in. If you remember, we use the keyword in for loop, right? So why we can use that? Because in and then the variable or an object after, like followed by that follows in, needs to be iterable, like range function. It enumerate numbers for us. It can be a list because a list can be iterable. Okay, it is a collection. Okay, then I have a question here. Before you print it out, maybe you can do it by hand, because in the exam it is a paper pencil exam, right? So please do it by hand and maybe give me an answer next time, next week. Okay, I have 2 minutes left. We'll see if we can go further. This one, so basic operations are done already. You can just understand that. And this is like list creation. We know before that we can create a like num and then equal to 1, 2, 3, 4, 5. Like for example, if we want to create a list of like from 1 to 1000, what we're gonna do is like this, right? Oh, okay, the class is at 10:30. Okay, I'm wrong again. Okay, we have plenty of time then. Thank you. Okay, like 10, 11, 12, blah blah blah, until etc. until like 1000 here. Is a lot, right? Okay, we're gonna use what we have known before. Let's see this. And okay, like we cannot write down like until 1 to like 1000. Okay, so we can use what we have known before to create a list by using just 3 lines. We know that actually lists can be modified. So we know that we can create an empty list first, and then we can append it, right, with 1. And append it, we can just gradually append it like with 2, and then do more, right? And then we can see that it is repeated. And when it is repeated, we're going to use for loop, or actually while as well. In this case, for may be easier. Okay, so the first method is like here, right? Wait. Oh, actually this is a like method 1.1 maybe. And this is method 1.2, like because it is manually assign each number to this list. Okay, method 2 is we can use for, and then and with the basic operations that we have known before. Okay, first we create an empty list, and then because we want to modify it, no, actually we want to add 1 to 1000. So we generate 1 to 1000 integers using range function here, right? Okay, and then what we're gonna do is we're gonna append each number inside, but because it is repeated, we can just write it one line, right? And then we change the fixed number here to be like to I, so that when I is changed, it's gonna change here as well, and then it's gradually append each number. Okay, okay, when I run this, oh yeah, actually it's not to 1000, actually it needs to be 1001 because I want to include 1000 here. Thank you, Nida. Okay, print out here, that's a lot. Okay, so when we know how to write a program more and more, and when we know advanced thing, we can do so many things. We can write down, this is just an example, like 2 examples that we can use for to create, right? There might be more. Okay, so this method is quite the same, but the difference is like here in the fourth line. Okay, for the first line, we first create an empty list, and then we use for to generate 1 to 1000 as well. And then instead of using the append function, we know that we can append the list by using a plus sign, like we want to concatenate the list, right? But the plus sign, we need to use it. We need to add, like, concatenate between 2 lists, because this is the list already. This is the num list already, right? So instead of like plus here, we need to create a list of size 1 just to make it as a list, so that they can be plus. Okay, they can be concatenated here. That's it. Okay, do you have any other way to do that? Yeah, while loop. You can use while loop as well. What else? Using count variable, yes. Or we can using the list modification by indexing as well, right? Because we know the index, we can use the index as well. Like maybe if I copy it here. Here, index of I, actually, right? And then print num here, if it is correct. And we cannot use this because this is, maybe I put question mark here. Because of what? Because at the beginning, the size of the list is 0, right? Is 0, okay? So, but here, okay, if I use this, what's gonna happen? Still, we cannot use this because index are of range. Imagine that, so if this is the size is 0, so we cannot use even the first index. We cannot use even the 0 index, okay? So imagine maybe this one might be easier if I have like a list of 4. So maybe call X, and then I want to add one more element at the end. Can I say that this is the index of 0, 1, 2, 3? I want to add at the 4th, right? I want to modify the 4th position from non, like there's no the 4th position, the 4th index position was not available before, but I want to assign kind of a number, maybe like 5 here. I cannot do this because this gonna access. This means that it's gonna access the index of 4, but the index of 4 is already out of range at the beginning, so we cannot do this. Okay, so this one cannot be done. Got it? Okay. Okay, so this is the list creation. There are many ways to create a list, you can see. And we can use for loop to create the list. If we know the value, like if we know the pattern of the value, we can use repetition pattern, repetitive patterns as like one single line or a few lines inside the for block to create that. Okay, maybe just one more example. If I want to create just maybe like the odd numbers from 1 to 1000, what can I do? Is that just maybe like step 2, right? I can specify the step is 2. That's it. Or I can have an if statement here. If I divide it by 2 and the remainder is equal to not equal to 0, I append. Otherwise, I don't append. Need to print it out. Okay. See, I can just keep the odd numbers already. Okay, so for loop or repetition, we know before that if you see the pattern repetitively, so we can just make it as a for loop. So we can write in far fewer code lines. Okay, the next topic is about list copy. Okay, let's copy here. There are 2 ways to copy. One is called shallow copy. The other is called deep copy. Shallow copy is here. Is when we have the data. We know data before, right? Let me copy it here again. Where is the data? Yeah, okay. There is here. Okay, what is shallow copy? So once we have a list of data, we have this diagram already, right? Okay, when we do d equal to data, it means that we're gonna assign data to another variable. What it does is that we create another container and then also a pointer to point to where the destination of the data pointer. Okay, it's the same. Even though, like for example, if we create a data equal to 4, and then when we say d like equals data, what it does is like this is data, right? and then this is for create a pointer because there is an assignment here. And this line, the program will create D here, and then the pointer to 4 as well. Oh. No, actually. Oops. Yeah, actually the pointer to 4 here. But because this is an immutable, this is an immutable variable. When we say again data equal to 5, what happened is that 5, the program will create a box, another box of 5 that contains 5, the value of 5, and then delete this pointer. My pencil is running out of battery. Give me a few seconds. As Apple advertised that we can charge a pencil with a few seconds, and then it should work. We'll see. Okay, it creates a 5 here, and then create a pointer as well, and then delete the previous pointer here. So if we print out what is the value of data, okay, it's 5 here, but what is the value of D? It's still 4 because the pointer is still here, right? Because this is immutable. Okay, we'll see in the case of list. Data is a list, so what it points is the a multiple containers, a collection of containers. And then because it is a containers, it points to the value later on inside, right? When we assign this to D, what it does is it does the same thing. It creates a container named D and then a pointer to point to the destination of the data's pointer, which is the list, which is mutable. Okay, when we change this list, we can change by adding another container, right? Using an append function, maybe to 5, for example. What happened is that when we print out what is the values of the data, so because the data points to this collection, so it's gonna print out like the whole list. It means that okay, I'm gonna go back a little bit. That how 5 here, how 5 here happens. It happens because maybe I use data.append 5, right? Okay. Okay, and then if I print out data, we can see that, oh, it's gonna print 5 at the end, okay? But if we say that if we want to print D, what happened? Because D is pointing to a collection of containers as well, the same collection, the same containers. So D will have the same value as data, even though when I append only to the data variable, not D. This will give the same results because it is mutable, because what it points to is mutable. It's different from this case, right? Because it is immutable. When I reassign like data is equal to 5, it create another pointer and delete the previous pointer because the 5 here is newly created in the memory. That's why this pointer of D is not affected. And when I print out data, it gives me 5, right? But when I print D, it's still 4. Okay, that's why, because when I change the data using append function here, it also changes the value of D as well. That's why it is called shallow copy. Okay, I can write it down here. See, oh, what is this one? Okay, not append data, append 5. Here, see? Okay. Maybe I have written another one. If maybe I put this one in the same box as here, but if I change maybe none here. This is the other example that I gave it before. Num, right? And then for this one, I change num to 5. We can see that it is different. See, it is different because num is immutable. This data is mutable. Okay. Next is oh, this is now right. Let me move this. Okay. Okay, so if we want to just copy a list to another list without like, and we don't want the effect previously. So what we're gonna do is there are 4 methods here that I show here. Okay, first, let me do this first. Okay, let me show you the second method first. So first is that we're gonna like create a D2, right? With an empty list first. So it's gonna point to a new collection, a new containers. And then I just access each item in the data and then append to the new list. Okay, so this is quite intuitive. We just copy an item one by one to a new list. Okay, this is one way. Another way is this one. This one is like data we need to concatenate with something. If we concatenate with something, it means that this is gonna give you a new list, right? Like A plus B is already a new list, and a new list is floating around in the program. That's why we need to cache it with a variable. Okay. So, but we don't need to like modify the list because we just want to copy it exactly what it is, so that we can use an empty list to concatenate with the data. Okay, so this is kind of working around to copy it, to do the deep copy to a new list. Okay. Okay. And the third method is because we can do the slicing, and slicing gives you a new list as well. Like remember that if we slicing like 1 to like from the first index position to the 5th index position, it gives you a new list, a list of multiple elements that are extracted. Similarly, we can use that, like we extract from the first element to the last element, and then this gives you a new list already. This gives you a new list. So a keyword here is like you need to create a new list, and once you have a new list, everything gonna copy it in a deep manner. And this gives you a new list, right? Okay. And also this one gives you a new list as well, because remember that we can convert a floating number to string using string function. It is a built-in function. This time we can convert data into lists as well, because later on we're gonna learn more about other collections. We have set, we have tuples, we can convert it into list type. Okay, so because data is already a list, right? That is fine. If we want to create another, like a new list, we can just convert it again to a list. It's fine, right? Okay, and this function returns a list, and then we use this variable to cache it. Okay. Why do I copy it here? I need to move it up. That's it. Okay, this is, oops, too much. Okay, so this is just an original values of the data here. Okay, so for copy list, you understand everything, right? You got it? Any question? We're gonna go further to the last topic of this lesson already. So we're gonna achieve what we expect. No, actually it is not the last topic. Okay. Okay, this is list comprehension. Actually, the list comprehension is when we want to create a list. Remember that we can create a list using for loop, or we can create a list by hand like this, right? For example, if we want to create an integer, a list of integers from 1 to 10. Actually, I need to plus here. Okay. You know why I need to plus 1 here, right? Otherwise, it's gonna create a list of 0 to 9. Okay. But for this, we have a comprehensive manner to write a code to a single line, like to shrink like these 3 lines to 1 single line. Okay. What we're gonna do is that we can do this. Okay, first, because the list comprehension, like what we want is just to create a list. So, and we want to name it as X. So X equal to a list, right? And then inside, we want to iterate 1 to 10. We need to use for loop, right? Because we need to append it. What I can do is here. First, okay. For here, like this line is not necessary anymore because it is a list already. Okay, and then I copy this line here without a colon at the end, without a colon at the end. Okay, so it means that, okay, please enumerate the number from 0 to 9, please. And I will use what it is iterated, which is I, to be an element or a member in the list. And then I need to plus 1 as well, right? Because so for the first iteration is I is 0, and then a plus 1. So the first value that I can get is 1. And then when I write in this way, it means that it's gonna put, so this is where we want it to be a member in the list. And then okay, so for the first iteration, I is 0, so 0 plus 1, which is, so I calculated it. Okay, so it's 1 already, right? Okay, and then I put it here because I want it to be a member in the list. And then for the second iteration, I is 1, and then plus 1 becomes 2. So it's the same as this command. Okay, so it is kind of a shorthand of the for loop here. Okay, so 2 here, and then for the third iteration, I will be 2, and then plus 1 will be 3, and then it will append in at the end of the list automatically without using append function. Okay, this kind of is shorthand of these 3 lines. That's why we call list comprehension. we use it when we want to create a list, because we want to specify what is the members in the list using for loop. Okay, here, and then we can print X out. We can see that we can get the same answer or the same output as we write a traditional for loops here, or classical for loop. Yeah. When you are confused about how to write a list comprehension, maybe you can write a classical way first, and then you can see the pattern. We copy it for loop here, and what is inside here, it needs to be like what is append here, it needs to be like just put here without append function. Okay. Okay, and for example, if the classical for loop that I want to create the odd integers, so I have if inside, right? Oops. Okay. Actually, can I change this? Just maybe also need to plus one. Actually, you can change what you're gonna enumerate numbers like here, or we can just use plus one here. It's the same. Okay, I use plus one to make it seem more complex. just to make it seem more complex. Okay. Okay. What I want is like 1, 3, 5, 7, 9. I want to create a new list of this number. Again, this is a classical way. I can comprehend it into just one single line here. Starting from, so let me do it again together. Okay. What I do is like I create an empty list, and then I put 4 inside here. Okay, and then if there is a condition here, I can put if inside here. And then what values that I want to add as a member is 1 plus I plus 1. I put it in the front here and space here. You got it? Any question? Okay, I got the same values here. Okay, this is the question maybe for your homework, that given a list of info here, can you do, what do you want to do? Create a new list named info int that contains only integers of the given list info using list comprehension. How to check if it is an integer? You can check if like you can use type, like type 2. You can see that. Oops. Okay. Type 2. What else? If you use type function, it is integer, right? So you can check like this. If type equals to int, if this is keyword, and then this return. This gives you a true value. Okay. Okay. So I give you a clue like this, and then I will leave it as your homework. And the last topic here, we will go very, very fast. Yeah, is that string. You know that we can consider string as a list of characters, like string like this, right? Okay, we can access each individual character using indexing. Here, indexing a positive index system. We get P individually, right? Also, we can use a negative system as well. Here, we can use index slicing as well, 3 to 8. Index 3 gonna be here, 8 gonna be somewhere. 8 is here, so it's gonna extract, including space here. So imagine that string is a character of a list of characters. So we can use in keyword to check if a substring, right? In the string or not. Okay, is not in the string because is space a is a string in the text. You got it, right? Because it needs to be exactly the same. But one thing that is unlike list is that string is immutable. So we cannot, because list of characters actually we can modify, right? We can modify a list, but we cannot modify a string because a string is immutable. What we can do is, if you want to change Python like a snake to programming language here, we need to reassign the whole string. Okay. And this one is an example of string functions or string operations. This is a string, and then you can see that. This is a function to check if it is alphabet, if it is number, if it is a digit, if it is lower or uppercase, but this will force every character will be lower, every character to be split upper, and this split function you have known before. Okay, that is all for today. We cover all the contents here. What I want to focus a bit here is like not exactly because actually a list of character is like this, right? Like P Y T, something like this. Okay, we can modify it, but for a string we cannot modify. Okay, sorry that I over okay, so see you next week because this Friday is and please do the programming exercise as well and post it on Microsoft Teams. Okay, bye bye everyone.